Hi, this is lead code question. Count number of possible root nodes. This is the last question of biweekly contest number 99. In this example, the answer is 3, and that means that there are 3 roots that has at least k, which equal 3 correct guesses from this array. So root 0, root 1, root 2 has at least 3 correct guesses, and root 3, root 4 has less than 3 guesses. For example, if we take root 0, we have 1, 3. 1, 3 is a valid or correct guess, since 1 is parent and 3 is child. Then 0, 1, 0 is parent, 1 is child. 1, 0 is incorrect. 2, 4, 1, 0 is incorrect, since 1 is not the parent of 0. 2, 4 is correct guess. So in total we have 3 correct guesses, which is greater than or equal to k. This is why root 0 is a valid root. So in total we have 3 roots. Now how can we solve this problem? Assume that we have this tree, and this is the array of guesses. The first thing we will do is doing DFS function on any selected node. Let's say we picked this node as a root, node 0. So we'll visit all the nodes, and while doing that we will find all the edges that exist on the guesses array. So start from node 0. Let's say we visit 4. So now we have 0, 4. So we push to the edges set. The edges set is the set that contains all the valid edges that exist on the guesses vector. Now, to check if this node 0, 4 exists on this vector, to make it faster, we change the vector into a set in order to get log of n search instead of n. So guesses set contains the same values of the array guesses, but in a set. Now edges set will contain all the edges we visit, and those edges exist on the edges set. For example, we start at root 0. Now we visit 4, so 0 is the parent, 4 is the child. We have parent and we have the node. So 0, 4 is 0, 4 exist on the guesses set. That's what we are doing here. If yes, we will add it to this set. So we have 0, 4. Then 4, 3. 4, 3 does not exist on the guesses array, so we don't insert it. 4, 2, also 4, 2 does not exist. Now 0, 1. 0, 1 exists, so we insert it to the array. Then we have 0, 6. 0, 6 does not exist. And we have 6, 5. 6, 5 it does exist, so this is 6, 5. Then we have 5, 8. 5, 8 is not in the array. Then we have 5, 9. 5, 9 also is not in the array. we are done with 5. Then 6, 7. 7 is not also in the array. So for root 0, we are done with this DFS. We call it only once in the root 0. Now we have this set contains of 3 values. We check if the size of the edges set greater than or equal to 3. That means the root 0 is part of the answer, so we add to the answer the value 1 in this case. So answer equal 1. Now the second phase is we are going to do another DFS call, but this time we will take an advantage of the previously collected set, and again we start from the node 0 but its neighbors. So in this loop here we visit all the neighbors of 0, so we need to find the solution for this. Because 0 we already find its solution, we need to find the solution for 4, 1 and 6 first. Let's start with 4. So we visit from 0 to 4, and because we came from 0, 0 is the parent. That means now we are at 4. This is we consider this as our new root, so the new root is 4. Now we came from 0. We need to check if 0, 4 exists on this set. If yes, we need to remove it, because this edge now, because the root is 4, becomes 4, 0 instead of 0, 4. So first thing is to check if this parent node, which is 0, 4, exists in the edges set. If yes, we delete it. So we remove 0, 4 and we replace. We need to check if 4, 0 now, because now we are at root 4. So 4, 0 is this new edge. So 4, 0. We need to check if 4, 0 exists on this array. 4, 0 does not exist, so we just ignore it. And that means the root 4 is not part of the solution. Then we continue our DFS. Note that here, after we finish from DFS, so we visit all the node until the leaf node. Now when we return back to the node, we reset the status of the set as it was before, in order to calculate for the other nodes like 1 and 6. So we set 4 is not part of the answer, and 0, 4 is removed from the edge set. Then because we are doing DFS, now we visit 3 again. 4, 3, because we came from 4 to 3. Is 4, 3 in this edge set? No. Answer is no. Now we need to check if 3, 4, because now our root is 3. Is 3, 4 in the array, the cases array? Answer is no. That means 3 is not part of the solution, because we have only 2 edges. Now we are done from 3. we go to the other branch, which is 2. Now 4 2 is 4 2 in the edges set. The answer is no. Now we need to check if 2 4 is on the guesses set. Since our root now is 2, is 2 4 in this set? The answer is no, so we don't do anything. Now we're done with 4. Because we are done with 4, we return the edges set to our initial state. So edges set return to 0 4 0 1 6 5. This is what we are doing here. So we're done with 4, and we sit here. We will visit all the neighbor of the root, and we go to this branch 0 to 1. Now again, is 0 1 in the edges set? Question. The answer is yes, so we remove it from here, and we need to check if 1 0 is on the guesses array. 1 0 is not in the guesses array, so we don't add it. And here we have only 2 valid guesses, so the root 1 is not part of the solution. We are done with 1, so we return back the edges set to its initial state. So now we have 0 4 0 1 6 5, and we visit next node 6 here. Now is 0 6 in the set? The answer is no. Is 6 0 in the guesses list? Because now the root, this is the root. Is 6 0 in the guesses list? Let's see. 6 0 is not there, and our set, we said it has 3 items: 0 4 0 1 6 5. So 6 is part of the solution, so we increase the answer by 1, so it's 2. Now we need to visit from 6 this node. Is 6 5 in this set? Yes, so we remove 6 5. 2 items remains, but before that we need to check is if 5 6, which is the opposite because this is our root now, is 5 6 in the array guesses. 5 6 is in the array guesses, so we insert 5 6 to the set. So this is what we are doing here, and the set is contain 3 values: 0 4 0 1 5 6, which is greater than or equal to 3, so 5 is valid root, so we increase the answer by 1. Answer is 3. Then we visit 8. 5 8, is it in the edges set? The answer is no. Now 8 5, 8 5 is it in the guesses array? Yes, so we insert it here. We have 8 5, then we have 1 2 3 4 valid guesses, and so 8 is valid root. We increase our answer to 4. We are done with 8. Now at 5 we reset the edges set as it was. So we have now 3 0 4 0 1 and 5 6. Now we visit 9. Is 5 9 in this edges set? The answer is no. is 9. 5 is in the guesses array. The answer is no. And still we have 1, 2 and 3 valid guesses, so 9 is part of the solution, so we increase it by 1. We are done from 9 to 5. We are done with 5, so we reset this edge set as it was before visiting 5. So we have 0 4 here, 0 4 0 1, and then we do reset this, and instead of 5 6 we have 6 5, as you can see here, because we are returning back to this node. Now 6 5 is exist here, so still we have 3 nodes, 0 4 0 1 6 5. Now we need to visit 7. Is 6 7 in the edge set? No. Is 7 6 in this array? Answer is no. But we have 3 valid guesses, so 7 is part of the solution, so we increase it by 1, and the answer will be 6. Time complexity of the solution is big O of n log n.